Example 4.4 is going to see us using a double angle formula just backwards. Here we are trying to evaluate the definite integral between 0 and pi over 4 of the square root 1 plus cosine of 4x. Let's remind ourselves of what double angle formula we might be able to use here. We see a 1 plus cosine of 4x, and that, to me, looks like a cosine squared of x equals a 1 plus cosine of 2x divided by 2. So if I just rewrote this, instead of x's, I let them be 2x's, I can rewrite cosine squared of 2x as 1 plus cosine 4x over 2. I can throw that 2 over to the other side, and 2 times cosine squared of 2x is equal to 1 plus cosine 4x. So our integral becomes the integral between 0 and pi over 4 of the square root of 1 plus cosine 4x, but that's equal to 2 times cosine squared of 2x. We can distribute that power, that square root, across the product and write it as square root 2 integral 0 pi over 4, and the square root of cosine squared will just give us absolute value cosine 2x. Now, if we think about the values of cosine 2x between the angle 0 and the angle pi over 4, if I take 2 times that x value, I get this entire first quadrant. And cosine values are always positive in that interval, so we really don't need this absolute value. Now, cosine of 2x with respect to x anti-differentiated will be a division by 2 sine of 2x. And I almost wrote plus c there, but we don't need that because this is a definite integral that we will run between 0 and pi over 4. When you do this, you get square root 2 over 2 times a 1 minus 0, or square root 2 over 2.